explain why freak waves shouldn't exist.
Using the linear model for a given sea state, this bell-shaped graph gives the probability of a certain wave height. And it's like in a population of children in a class. There is an average height of children, and most children are around that height. Some are quite a bit taller or shorter. There's the chance that a child is 3 or 4 times the height of the average child is very, very small.
So, according to the linear model, even in a fierce storm where average wave height may be 12 meters, the chance of meeting a 30-meter wall of water is practically zero.
Using the linear model for a 12-meter sea state, the chance of finding a 30-meter trough-to-crest wave height is 10 to the minus 5, which is 0.00001. To put it in perspective, a wave like that would come along using the linear model once every 10,000 years.
The linear model is so well accepted that the entire multi-billion-pound shipping industry relies on it. Meteorologists use it to predict wave height, and naval architects to calculate ship strength. And the biggest wave used in ship design is just 15 meters. The idea that there might be freak waves out there seemed impossible. Instead, any mysterious disappearances at sea have been blamed on far likelier culprits, like corrosion and human error. But then one day, something happened that forced scientists to look again at their ideas about ocean waves. On New Year's Day 1995, a storm was brewing in the North Sea. The Draupner oil rig was 100 miles out in the harshest of weather. The sensors were regularly reading waves of 12 meters. When suddenly, out of the blue, came a wave that was so high and so steep, scientists had thought it was impossible.
For me, it changed everything. Really changed everything. This wave is at 26 meters. It's so much bigger than the background sea state.
When the New Year's Day wave came along, which fits this picture, a 30-meter crest-to-trough height in a 12-meter sea state, alarm bells started going off because of the very low probability of this wave. Yet we saw it.
The sensors measured a wave so steep and so high it should only occur once in every 10,000 years. Suddenly, it seemed that the mariners might be right, after all. The New Year wave shocked wave experts. Among them, Julian Wolfram. He has spent years since then studying the same part of the North Sea, looking for more freak waves.
What we need to do is to study waves like this, because we need to know how frequently they occur, because if they occur quite frequently, they could actually pose a serious danger to offshore structures and ships.
Wolfram was looking for any waves that were bigger than the linear model would predict, and to measure them, he installed a radar device, looking down to the sea surface.
We have a device which faces down to the surface of the sea and basically sends out an electric pulse, hits the surface of the water and comes back again. And we time the amount of time it takes to go down and come back. And from that we can estimate the distance from the radar to the wave. And we do that continuously, so we actually get the profile of the surface.
Over 4 years, Wolfram measured every large wave that hit the platform. And when he plotted the size of these waves compared to the height of the waves around them, he found something completely unexpected. The linear model predicts that when you plot the height of individual waves relative to the waves either side, they should all lie on a straight line. And when the average size of the waves was small, the linear model held true. But he found 24 waves that veered well above the line. These biggest waves occurred far more frequently than the linear model predicted. It appeared that these 24 waves were a completely different sort of beast.
Well, one of the things we learned when we plotted out the graph was that in fact the really extreme waves are different from the slightly smaller waves. They have different characteristics. They tend to be significantly steeper. They also tend to be higher than we would normally expect based on the ordinary theories we've used up to date. They are unusual. They are freak waves.
It seemed Wolfram really had found the rogue wave of Mariner's myth. For the shipping industry, Wolfram's research could have been a disaster. If there really were freak waves out there, then potentially billions of dollars were at risk. It could mean having to redesign every single ship. With so much at stake, scientists needed to understand what was going on. Where did freak waves come from, and was there any way of predicting them? Searching for clues, they looked at where mariners had reported seeing freak waves and found one place where they seemed to happen over and over again. South Africa. The southern Cape of Africa is a major shipping route, with millions of tons of cargo being shifted every year. The seas here may look calm, but for years they have been notorious to sailors for the ferocity of their waves. Captain Di Davis is one of the leading salvage experts in South Africa. He's seen the damage these waves can cause dozens of times.
The Neptune Sapphire was a brand new vessel on a maiden voyage. It was as if a cutting torch had cut the ship in half, completely. Atlas Pride happened in horrific weather. This big wave just came out of nowhere, hit the bow and destroyed the whole bow. Mimosa, it was a very big vessel. The ship's side plating was punched in, completely smashed in, causing a hole to be formed you could fit 3 double-decker buses into. When I went aboard the ship to carry out the salvage, the captain, who was a very experienced Norwegian master, said it's the biggest wave he'd ever seen in his life, he'd ever seen.
Since 1990, 20 ships have been devastated by rogue waves off the coast of South Africa. Scientists like Martin Grundling decided to find out what was going on in these waters to make them so dangerous. So they plotted the locations of all the accidents on a chart.